Hello, San ma'am. A very good evening. I am Divya Devi, PG scholar from CMR College of Engineering and Technology. Uh, I am going to present my work, our work, performance analysis of rung ladder multilevel inverter with PV application. My co-authors are Professor Dr. S. Muthu Balaji, from CMR set, and Madam Sangeeta, Assistant Professor, CMR set campus. Our work objective is to implement rung ladder topology for renewable, one of the renewable energy sources, and we have selected a solar PV array as an input and analyze the behavior of the topology under steady state. A comprehensive literature survey has been done to analyze the topology and to perform steady state analysis on the topology with PV application. The various papers that has been studied have been presented under literature survey here. Now we are going to see on rung ladder topology. The rung ladder topology is a modified form of H-bridge where 6 switches are on the ladder, whereas two unit cells are in two rungs, where one is a 4-level creator cell FLCC. It consists of 5 switches and 2 sources, where it produces 4-level output, basic output, whereas SIBC, source inclusion bypass cell, provides us remaining levels, higher levels along with FLCC. This is the generalized structure of rung ladder MLI. Now, proposed system is to implement the solar PV panel along with MPPT technique to the modified rung ladder converter, which is supplying the load. Here is the more generalized structure of modified rung ladder structure. This modified structure, in this modified structure, and switch is eliminated in the SIBC, has the switching state of the switches are designed with a simple logic circuit. Here the ladder switches are helpful to have an one directional flow, that is positive and negative currents, whereas FLCC provides us 4 levels of voltages, and SIBC helps us SIBC unit with single switch and single source helps us to get remaining voltage levels. By increasing the number of SIBC cells, we can have number of higher voltage levels. With single SIBC and FLCC unit along with H ladder structure, 6 switches, we can have 15 level output voltage. This is observed using the switching states. Here are the switching states. Here are the various switching states where the switches are switched on and off in an order to get an particular voltage level. We can observe here. To this switching state. From the figure 3, where we can obtain voltage V1 from when SA, SB, SC dash are operating, and in FLCC unit S1, S2 are switched on. So S1 will be Here it provides the path to the V1 voltage which is connected positively across the load. Whereas to switch it to negative voltages, the same FLCC, there is no change in the FLCC, whereas SA dash, SB dash and SC are switched on. So therefore, as I previously explained, SA, SB, SC, SA, AC dash, SB dash, AC dash. This ladder switches are used to reverse the voltages, whereas FLCC is used to get the basic voltages. As we can see here, V1, V2 minus V1, V2 and V1 plus V2 are obtained using FLCC. V1 plus V2 minus V3, that is our fifth level, sixth and seventh level, can be obtained using SIBC along with FLCC. This is all about the switching, 7 switching state for 15 level output. Let us come to the switching table. Switching table gives us the clear idea of conduction time of each switch, where it also provides the idea of periodicity of switch on for each switch for a cycle, and it gives information of conduction loss for a period of each switch, and also the logic table. This is the logic table where logic table is developed by dividing the switches into two groups, where ladder switches are considered as a group A switches, Rung switches which is FLCC and SIBC unit switches are considered as a group B switches. Here the separate logic circuit is designed, switching circuit is designed for group A and group B switches. The logic sequence table provides us the view of each switch, working of number of switches for each voltage level. Now here the switching technique. That's in simple phase disposition level shifted PWM technique is developed for a modified structure where seven triangular carrier waves are used, and two sinusoidal reference wave is used to get the PWM pulses. This is the logic circuit for group B switches, which is designed using and logic gates XOR, XNOR, NOT and AND gates. This is the switching logic for group A switches, which is also designed using NOT and exclusive OR gates. Now comes the overall view simulation circuit of the modified rung ladder MLI with PV application. This is the overall proposed system where our topology is working under asynchronous mode with 3 voltages. In the voltage ratio of 3 voltages is 1:3:9, where 34 volts is the lowest voltage considered, which provides us the output of 430 volts, overall 430 volts, maximum voltage of 430 volts. Here inputs are not just an DC voltages but an PV panels, where PV panels are connected through converter circuit, which provides us the implementation of the MPPT technique, which gives us the opportunity to draw maximum power. Here P and O MPPT technique is considered for the sake of simplicity to draw the maximum power from the PV array. And single diode model PV array is used to design the PV array, and constant, whereas irradiation and temperature are considered constant. This overall system is designed and simulated in MATLAB 2016 version. This is the circuit model of PV panel, where IL current source is light generated current source, ID current through diode, and series and shunt resistances are shows the VI, represents the VI characteristics of the non-linear PV. This is the P and O MPGT technique that is used, where power is where maximum power is tracked by changing the voltages using the duty cycle. If the duty cycle is increased, voltages are. This is the overall output, where 15 level voltage output voltage waveform can be observed. THD levels can be drawn from FFT analysis. The THD levels of level of modified rung ladder is 9.34. The comparison between the two can be observed here. The main comparison is simple logic circuit requirement for switching the circuit, and another is the THD requirement is THD content is 9.34 when compared to rung ladder 13.9. Main working has been verified using simulation. Here the references. Thank you one and all.